All right, so we're continuing section 5.2. Where we left off was I had asked you to find all the vertical and horizontal asymptotes for the problems in that section. So now what we're going to do is we are going to graph a rational function, and I'm going to do 2 or 3 or 4 examples for you. So there are 6 steps. On your test, I am going to outline the 6 steps. You do not have to memorize these. Step number 1, as we already talked about, was vertical asymptotes. Vertical asymptotes, remember, happen where the denominator is 0. A graph will never go through the vertical asymptote. So for this graph right here, the vertical asymptote is where x minus 3 equals 0. And so then that means that's where x is equal to 3. So in a moment, when we graph, we're going to draw a nice dotted line, a nice force field at x equal 3. The horizontal asymptote, remember there's 2 situations, and go back and watch that video. This is the situation where the degree of the top and the bottom are the same. And so my horizontal asymptote is going to be y equal to the ratio of these 2 coefficients, 1 over 1. So that means that the horizontal asymptote is y equals 1. Now, the rest of our process is just finding a few points to see how does the graph interact with the asymptotes. Okay? Asymptotes define the behavior of our graph. So the first point, I like easy points. The first point is we're going to find the y-intercept. The y-intercept is where the graph goes through the y-axis, and that happens where the x value is 0. So I am going to plug 0 into my function. So in the top, I get 0 plus 2. In the bottom, I have 0 minus 3. So that is negative 2/3. So the graph is going to go through the y-axis at negative 2/3. The x-intercept is when the y value is 0. So it's when the function itself, so x plus 2 over x minus 3, has the y value 0. Well, the nice thing is a fraction is only ever 0 when the numerator is 0. 0 divided by anything is 0. So I don't even have to worry about the denominator when I'm finding the x-intercept. So when I add 2 to both sides of this, we get x is equal to 2. So right now, I've got a whole bunch of information. I did make a little mistake. That's negative 2. You probably caught that, and you were probably waving your hands at the screen. The next question is, does the graph cross the horizontal asymptote? Horizontal asymptotes tell us the long-term behavior of the graph. And while a graph can never cross the vertical asymptote, it can cross a horizontal asymptote, usually right around the origin where all the fun stuff's happening. So what you do is this. Does the graph cross the horizontal asymptote? I'm going to take my function, my x plus 2 over x minus 3. And I'm going to set it equal to the value of the horizontal asymptote, which is 1. So I want to know, does my function ever have the y value 1? Meaning, is it going to go through that dotted line? Now, I don't love how our book does this. I think our book should do section 5.3 before 5.2, but I didn't write the book. We've got to solve a rational equation here by clearing the fraction. And so what I'm going to do is I'm going to multiply both sides by the common denominator. We will talk more about this when we get to section 5.3. But for now, all you need to know is clear the fraction. On the left side, the x minus 3's cancel. On the right side, you have 1 times x minus 3, which is x minus 3. And now notice what happens. When I go to get all of my x's on the same side to solve this, the x's cancel everywhere, and I have the statement 2 equals negative 3, and I have just enough room. That's a false statement. That can never happen. There's no x there. So what that means is, does the graph cross the horizontal asymptote? No. So I can be rest assured that my graph, the horizontal asymptote, is going to be a nice firm barrier as well. So I'm going to come over to my graph board right here, and we are going to graph the information that we know. Hopefully you've been taking notes. So the first thing that I have is that the vertical asymptote happens at 3. So I'm going to come right here, and I'm going to draw a nice dotted line. The graph will never go through the vertical asymptote. Then I have a horizontal asymptote of y is 1. So I'm going to make a nice dotted line, dot, 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 right there. This tells me a lot about the graph. Now, my y-intercept, where the graph goes through the y-axis, is negative 2/3, so right about here. And then where it goes through the x-axis is at negative 2. And I know that the graph doesn't go through the horizontal asymptote. So I already know, since we're just drawing a quick sketch, this doesn't have to be perfect, I already know what the left half of the graph looks like. Okay? Because the graph's never going to go through these asymptotes, I'm just going to draw a graph. I've got to get in position. You know I'm bad with my art, everybody. Oh, that is perfect. Beautiful. So all I've done is draw a little curved graph that gets closer and closer to these two asymptotes without going through. So all that remains is I need a point or two on this side to figure out what the behavior is. So this is up to you. Pick as many points as you want or as few points. I'm just going to do 2 points just to help you know. Ordinarily, I'd probably even just do 1 since I know it doesn't go through the asymptotes. So we're going to go back over to this board. I'm going to erase this, rewind into the video if you don't have that information right there. And so I'm going to, since my vertical asymptote is at the value 3, I'm just going to pick the value, let's say 4, and then the value 6. You can pick anything you want. When I put 4 in, 4 plus 2 over 4 minus 3. So that's 6 over 1, or 6. When I put 6 in, 6 plus 2 over 6 minus 3. And that's 8 over 3, or 2 2/3. Okay, 8/3 is 2 2/3. So we're just about done with the problem. You'll get good at this after you do a few. So at the value 4, I go up 6. So 1, 2, 3, 4, 5, 6. At the value 6, so 5, 6, I go up 2 2/3, 1, 2 2/3, and that gives me all the information I need to complete my graph. And that is my sketch of a rational function.